In this video, we are going to take a look at how to graph reciprocal trig functions. So the first one that we are going to take a look at is the cosecant function. So remember that cosecant is the same as 1 over the sine function. So it is the reciprocal of the sine function. So let's think about, so reciprocal is just flip it over. So let's take a look at the sine of a few numbers. So let's do sine of 0. So if I kind of drew the first quadrant of the unit circle here, this first coordinate right here would be 1, 0 at an angle of 0. So the sine is the y coordinate, so 0 in this case. So if we're taking a look at cosecant of 0, remember that's going to be the flip of this. So remember this is 0 over 1. So cosecant would be 1 over 0 or undefined. If we took a look at, let's say, sine of pi over 4, okay, that's going to be here. The ordered pair of this, since it's the 45-degree reference angle, the x and the y are the same, so they're both square root 2 over 2. The y coordinate, square root 2 over 2. And let's just think about that as a decimal. It's 0.707. So if we take a look at cosecant of the same value, pi over 4, we would just flip this over. So it would be 2 over square root 2. So the decimal version of that is 1.4. Okay, so then let's take a look at sine of pi over 2 or 90 degrees. So that's going to be this one. So at 0, 1. So the y value here is 1. So the reciprocal of 1 for the cosecant function is going to be 1 over 1 or just 1. So a couple connections that you want to make here is that where the sine function is 0, the cosecant is going to be undefined. And where the sine is 1, the cosecant is going to be 1. Similarly, if we go all the way over here to pi, and we look at the sine of pi, so this ordered pair here is -1, 0, so the sine is going to be 0. The cosecant at pi is then going to be undefined, just like we talked about. When sine is 0, cosecant is undefined. If we look at sine of 3 pi over 2, or 270 degrees, which is right here. This is going to be the ordered pair 0, -1. So sine is going to be -1. Cosecant is going to be the flip of that. So we're going to do 1 divided by -1, which is -1. So when sine is 0, cosecant is undefined. When sine is -1 and 1, cosecant is the same. So at the maximums and minimums of the sine function, cosecant is going to be identical. At the zeros of the sine function, the cosecant is going to be undefined. So what we're going to do is actually graph the sine function like we've been doing. Okay, so sine has a period of 2 pi. So let's take a look on this graph and get that situated out. We don't have any phase shift. We don't have any vertical shift, so I can put those lines on here too. So your midline is still going to be just right here, and your phase shift is going to be at 0, so we're just going to be starting normal here. And then for 2 pi, so let's count to pi is 4 boxes, so to 2 pi is 8 boxes. So remember, we're going to split that in a fourth, okay, so that's going to be 2 boxes. So every 2 boxes, something's going to happen. So let's mark those. So from the phase shift, so 2, 2, 2, 2, okay, backwards as well, every 2 boxes. Sine starts at a middle, okay, so sine starts at a middle. Sine of 0 is 0. Then sine goes to a max, Okay, so the amplitude here is 1, so we're just going to be up at 1. So if you wanted to have those amplitude lines on there, you could as well. So our amplitude is 1. So sine is a middle and then up to a max, down to a middle, down to a min, back up to a middle, and then backwards it would go down to a min, middle, max, middle. So now instead of actually graphing the sine function, okay, which I'm going to do it right now just to show you. So this is where the sine function would be. Okay, so there's that sine function. So instead of graphing that, remember that we are graphing the cosecant function. So I'm just going to put this sine function in there dotted so that you can see it, but we're not going to actually graph it. But that's where it would be. So we're going to be graphing the cosecant function. So remember, when sine was 0, cosecant is undefined. So when sine is 0, cosecant is undefined. There's an asymptote there. Okay, so every time sine is 0, cosecant has an asymptote. Okay, so drawing those asymptotes, I should probably just use the segment drawer because this is not going well. Okay, let's do the segment drawer. Okay, so you've got asymptotes everywhere that sine is 0. And then when sine was at a maximum, so was cosecant. Okay, so everywhere sine is at a maximum, cosecant is the same as that. Everywhere sine was a minimum, or this -1, cosecant was also a -1. So at the zeros, you're going to have asymptotes. At the maxes and the mins, you're going to have the same point. Then remember what happened here. Where sine was 0.7, cosecant was 1.4. So it actually grew from there. So this is what the cosecant function is going to look like. Up from the maxes and down from the mins. It's got kind of a parabola there. So it just gets really close to those asymptotes. Doesn't cross it. So up from the maxes, down from the mins. So if we have a period change here, so cosecant, okay, again is 1 over sine. So we're going to graph the sine function, and we're going to deal with the shift, or with the period change here. So your b value is 1/2. So your period is going to be 2 pi divided by 1/2, which is 4 pi. Okay, so count and figure out how big 4 pi is on this graph. So here's 1 pi at 4 boxes. So 4 pi is going to be 16 boxes. A fourth of that is 4 boxes. So let's get our midline on there. So our midline, we have no shift there. So we have no k value. We have no h value on the inside, added or subtracted. So we're still going to be at the y-axis there. The amplitude is 1. Okay, then deal with the period. So every 4 boxes starting at this phase shift. And then backwards as well. So now plot the sine function. So remember, the sine function starts at a middle. Okay, then the sine goes up to a max, back to a middle. Okay, and we're going every 4 boxes for this period now. So down to a min, backwards, back to a middle. So here's the sine function. Again, I'll just show you, but I'm going to delete it. Okay, so there's the sine function. 1 period of the sine function in 4 pi. Okay, so now when we go to graph the cosecant function, remember that there are asymptotes at the zeros. So wherever sine is on the midline, there's an asymptote. Okay, so at those 3 zeros. And then where sine is at a min, cosecant happens. And where sine is at a max, cosecant happens. Then you draw the parabola up from the maxes towards the asymptotes, down from the mins towards the asymptotes. So secant is going to be much the same, except that secant is 1 over cosine. Okay, and now I've just changed the scale to be in degrees this time instead of radians. So for this one, we don't have a vertical shift. Okay, so we're just on the x-axis. There's no k value here. We don't have an h value, so we'll still be on the y-axis. And our amplitude is 1. Whoops, didn't change colors. I'll change that in a second. Okay, so our amplitude is at 1. All right, so now what you're going to do for this one, since secant is 1 over cosine, you are going to graph the cosine function. Okay, so you're going to deal with the period of the cosine function as 2 pi. Okay, on this graph, well, not 2 pi since we're doing degrees, so 360 degrees. Okay, on here, 360 degrees is 8 boxes. So 1/4 of that is going to be 2 boxes. So every 2 boxes, we're going to be hitting a min, middle, or a max, starting at the phase shift. So every 2 boxes. Cosine starts at a maximum, okay? So when we're on this phase shift, cosine is going to start at a max. Then it's going to go to a middle, min, middle, max. Backwards, it's going to go middle, min, middle, max. So again, if you were to draw the cosine function in, it would look like this. Okay, but we are drawing the secant function. So the secant function, again, where cosine is 0, secant is going to have an asymptote. But I'm going to change the color this time because we already have red for the phase shift. All right, so at these zeros, you're going to have asymptotes. So here, 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 and here. Okay, at all of the places that cosine is 0. And then where cosine is at 1 or at its max, secant is going to match. Okay, so at the mins and the maxes are going to be the same. So it's going to go up from the maxes, down from the mins. So at every minimum, you're going to have a parabola going down. At every maximum, you're going to have a parabola going up. And then again, these asymptotes happen when cosine is at 0. So if we're going to take a look at this one has a bit of a shift with it and a change in the period. So for this one, let's go ahead and put the midline in. So there's no k value here, so the midline is still going to be the x-axis. Phase shift is going to be 45 degrees, so we've got 180 here. Divided by 2 would be 90. Divided by 2 would be 45, so one box is 45 degrees. This one is x plus 45, so that means that the number plugged in here is actually negative 45, so that's going to be a left shift of 45. Then we have a b value of 2, so we're going to do 2 pi divided by 2. Well, not 2 pi, sorry, because we're in degrees on this. So 360 divided by 2. So our period is going to be 180. Okay, again, on this graph, 180 degrees is equal to 4 boxes. And then we want to split our period in fourths for our mins, middles, and maxes. So a fourth of 4 is 1 box. So every 1 box from this phase shift, so starting here, every 1 box is going to be a min, middle, or max. Okay, so every box. You can put all these little dashes on here if you want, or you can remember it's every box. So now we're going to plot the cosine function because secant is the flip of cosine. Okay, it's the reciprocal of cosine. So, oops, I didn't put my amplitudes on there. So amplitude is 1. So we'll put these lines on there too. Okay, so cosine is starts at a maximum. So on this phase shift, we're going to start at a maximum. Then every one box, it's going to go middle, min, middle, max. Okay, so middle, min, middle, max, middle, min, middle, max, middle. Okay, then backwards, it would go down. So middle, min, middle, max, middle, min, middle. So that would be the cosine function. So now you need to do the secant function. So you need to do asymptotes at all of the places that cosine is 0. So on this midline. So everywhere that cosine is 0 on the midline, you get an asymptote. Okay, then remember that it goes up from the maxes, down from the mins. So this one's a min, so we're going to have a parabola down towards the asymptotes. Never crossing them, but getting close. Okay, up from the max, down from the min. Okay, here's a min, so we'll go down. Here's a max, so we'll go down. So in between every set of asymptotes, you have either an up parabola or a down parabola. And then you have your secant function.